Hello my dear students, welcome back to your channel. Hope you all are doing well. Today I am going to start quick revision of chapter 15 of class 11th physics, that is waves. In this chapter, different topics to be covered are: first, what do you mean by waves and their types, then mechanical waves, and these are two types, transverse and longitudinal mechanical waves. After that, speed of traveling waves and displacement relation for a progressive wave. Progressive or traveling wave is same. Then principle of superposition of waves and its different applications like stationary waves, beats, interference, then reflection of waves and standing waves in case of strings and organoids. That is very important. So I will cover each topic one by one. Let us start first with what do you mean by waves or wave motion? Okay, wave is nothing but it is a form of disturbance which travels through a material medium due to what? Due to repeated periodic motion of the particles of the medium about their mean position without any actual transportation of matter. Right? Suppose a disturbance is created at this point. Now, at this point, the particle starts vibrating about their mean position. This is the original position, means mean position. Now the particle starts moving to and from motion, like it executes simple harmonic motion. And during their vibration, it just transfers their energy to the next particle and it returns back to its original position, mean position. Again, the next particle transfers their energy to the next particle and it vibrates around their mean position. So particle starts vibrating about their mean position, right? By the transfer of energy. So actually energy is transferring from one point to another point. This energy is nothing but disturbance. Disturbance is traveling from one point to another. Particle only vibrates about their mean position, right? So it is a form of disturbance which travels through a medium. Due to what? Due to repeated periodic motion of the particles of the medium about their mean position. And in this transfer, only energy is transferred from one point to another. There is no actual transportation of matter. Only energy is transferred from one point to another. That energy is nothing but disturbance. And when a source of energy causes vibration to travel, a wave is created. During the motion, wave travels, it means disturbance or energy travels from one point to another point, and the wave velocity is always constant in a given medium, but particles vibrate about their mean position. So at mean position there is maximum velocity, you already know, study in chapter oscillation, and at the extreme position its velocity is minimum. So the particle velocity changes are variable. It is maximum at mean position, minimum at extreme position. These are about wave motion. Now there are different types of waves: mechanical waves, electromagnetic waves and matter waves. What do you mean by these mechanical waves? Mechanical waves are those waves which needed material medium for their propagation. In this mechanical wave, medium is needed for propagation. It is governed by all the Newton's laws of motion. For example, water waves, sound waves. These waves requires medium for their propagation, right? So these waves are mechanical waves. Second one, electromagnetic waves. Electromagnetic, as the name suggests, these waves are related to electric and magnetic field, and these waves does not need a medium to propagate. It carries no mass but still transfer energy from one point to another point, like satellite system, mobile phones, radio, music, all these are electromagnetic waves are created, right? Then third one is matter waves. Matter means it is related to moving particles. These waves are associated with moving particles of matter like electron. Every matter is made up of what? Molecules. Molecules are made up of atoms and atoms are made up of electron, protons and neutrons. So these waves are only generated when these particles are moving. Electron, proton, all these particles are moving, then matter waves is produced. For example, sun, moon, earth, ball, atoms, pencil, all when it is in motion, matter wave is produced. So we will discuss in detail about mechanical waves in this class 11th, and these electromagnetic waves and matter waves will discussed in class 12th, right? So first, what do you mean by these mechanical waves and what are its different types? Okay, so first you know what do you mean by mechanical waves. Mechanical waves are those waves which requires material medium for their propagation. On the basis of direction of propagation of wave and particle motion, these are of two types. One is transverse wave and the one is longitudinal wave. First, what do you mean by transverse wave? Transverse waves are those waves in which particles of the medium vibrate at right angles to the direction of propagation of wave. Wave is propagating in one direction and particles are vibrating at right angle to the direction of propagation of wave, right? So these are called transverse waves. For example, suppose a man is holding a thread at one end and another one is fixed to this wall, right? When a little jerk is given at this point, what happens? In upward direction jerk is given, the entire thread moves in a wavy manner and transverse wave is produced, in which wave is propagating in this direction and particle is moving perpendicular to this direction of propagation of wave. So in case of waves on a string, transverse wave is produced. It is also produced on surface water waves, right? Electromagnetic waves, all these are transverse waves. These are examples of transverse waves. When transverse wave is produced, it always travels in the form of crest and trough. What do you mean by crest? Particle vibrates about their mean position, original position, mean position. So maximum displacement in the upward direction is crest and maximum displacement in the downward direction is trough, because particle is vibrating in upward and downward direction, perpendicular direction of propagation of wave. So in upward direction, maximum displacement, it forms crest, and downward direction, maximum displacement, it is called trough. So it travels in the form of crest and trough, right? And it is produced only in solids because they have rigidity, or also on the surface of fluids due to surface tension, right? Next one is longitudinal waves. What do you mean by longitudinal waves? In this one, direction of propagation of wave and particles of the medium vibrate in the same direction. Suppose this is direction of propagation of wave and particle is also vibrating in the same direction. So these types of waves are called longitudinal waves. For example, sound waves. Sound waves are longitudinal mechanical waves, right? And it can be produced in all types of medium, whether it is solid, liquid or gaseous. It can travel through all three mediums. When it travels in the form of compression and rarefaction. When particle vibrates in the direction of propagation of wave, it forms higher density region and lower density region. This higher density region is called compression and low density region is called rarefaction. So this wave travels in the form of compression and rarefaction. These are also called pressure waves. After this, there are different terms related to waves. You already studied in previous chapter oscillation. So again, we are just going to revise all these terms. Suppose wave is formed in this manner, right? So first term is, what do you mean by wavelength? It is distance between two nearest points in a wave which are in the same phase. Suppose this point and this point are in the same phase. So distance between this nearest distance between is called wavelength. Or distance between this one and this one, both are in same phase. This is called wavelength. You can also define in case of transverse wave, this one is crest. So distance between two consecutive crest or two consecutive trough are called wavelength. Or in case of longitudinal wave, distance from center of one compression to another. So you can define wavelength. It is denoted by lambda. Next is amplitude. It is maximum displacement of the particles of the medium from their mean position. This one is mean position. Maximum displacement in the upward direction or in the downward direction. These are called amplitude. Time period, time taken to complete one vibration is called time period, denoted by capital T. And frequency is number of vibrations completed in 1 second. This is called frequency, 1 by T, and its SI unit is Hertz. After this, next important term is angular frequency. In case of linear motion, linear frequency is there, but when we are dealing with waves, in which it means it is related to circular motion. So angular frequency is used to define the frequency of the wave in terms of circular motion. It is denoted by omega. And what is relation between omega, this one is angular frequency, and linear frequency, nu. So omega is equal to 2 pi by T. In T time period, 2 pi is the phase difference. So 2 pi by t and 1 by t is frequency. So 2 pi nu, you can write 2 pi by t. This is angular frequency. Now there are two types of velocity. One is wave velocity and the other is particle velocity. So wave velocity, when an energy is propagated in one direction or disturbance, wave is produced. So the velocity of the wave is constant throughout the motion. The distance traveled by wave in 1 second is called velocity of wave or wave velocity, and it is given by wave velocity is equal to frequency into wavelength. But what do you mean by this particle velocity? The particle vibrates about their mean position, and during their vibration at mean position there is maximum velocity and extreme position there is minimum velocity. So this velocity is changing or variable. Particle velocity is variable. It is equal to dy by dt. Velocity of the particles executing simple harmonic motion is called particle velocity. One thing must remember in your mind that this wave velocity is constant and this particle velocity is variable. After that, there are one or two terms. One is important term is wave number and then angular wave number. Wave number is nothing but number of wavelengths per unit distance, and it is denoted by, you can write it as 1 by lambda, right? What do you mean by angular wave number? It is also called propagation constant because it is about the propagation of the wave. So that's why angular wave number is called propagation constant. It is given by k equal to 2 pi by lambda. K is called propagation constant or angular wave number. It is equal to 2 pi by lambda. Now suppose this is figure, this one maximum displacement is amplitude. This from this points, distance between two nearest points which are in the same phase is called wavelength. Particle is moving in y direction and wave is traveling in this x direction. So this is the diagram for transverse wave in which crest and troughs are formed. So these are about different terms related to waves. Now next is what are different essential properties which are required for a medium for the propagation of mechanical waves. In all types of medium, wave cannot be propagated. Only there are some properties of medium for the propagation of mechanical waves. First one is elasticity. Why elasticity is required for the medium? For the particles to return their minimum position after being disturbed, the medium must possess some elasticity, then only they return to their original position. So the medium must be elastic medium for the propagation of mechanical waves. Second one is inertia. Inertia means it is related to mass. Mass means it can have some kinetic energy. So the medium must possess inertia or mass so that the particles can store kinetic energy. So these two are important and essential conditions of a medium for the propagation of mechanical waves. Medium must be elastic medium and medium must have some inertia so that it can store kinetic energy. Now third one is also important, that is minimum friction. The frictional force should be negligible so that they continue oscillating for a long time and also it travels through a long distance. So the medium must have minimum friction. So all these three are essential properties of a medium for the propagation of mechanical waves. Now after this, I'm going to find a speed of transverse and longitudinal waves in different types of medium. So you know transverse wave can only travel through this solid and on the free surface of the liquid, right? And also the wave velocity travel through a medium depends on two factors. One is inertia and another one is medium must be elastic medium, right? These two factors are responsible for the travel of wave, right? And in case of a stressed string which provides elastic, this tension T in the string. T is tension in the string which measures elasticity of the in the string, and this inertia is this one, mu is mass per unit length, right? And this is this provides inertia in the string so that it can store kinetic energy. So both inertia and elastic factor are responsible, and this speed is given by a stress is under root T by mu. T is tension in the string and mu is mass per unit length. This provides inertia in the string and this tension in the string provides elasticity. and both are responsible for the wave to travel in a stressed string. So its velocity is this one. In case of solid, it is given by under root eta by rho. This density provides inertial factor, and this eta is called modulus of rigidity. It provides elasticity in the medium. So you must remember one thing, that velocity is also given by under root. In the numerator, this one is elastic factor is there, and in the denominator inertial factor is there. So it's easy to remember the formula for velocity in case of this stress string. Elasticity means tension provides elasticity, and this mu mass per unit length, it is also called this one mass, linear mass density. It provides inertial factor. Its unit is kilogram per meter. In the same way, what is the speed of longitudinal waves? Longitudinal wave can travel through all solid, liquid and gases. In case of elastic medium, it is given by under root y by rho. This rho is density, y is Young's modulus of the medium. So this rho provides inertial factor, and this Young's modulus provides elasticity factor. In case of fluids, this y is replaced by e, or you can say b. This b is called bulk modulus of the elasticity. It provides elasticity in the medium, right? And this rho is inertial factor. It provides, through this it can store kinetic energy. So in the numerator always elastic factor is there, in the denominator always inertial factor is there. In this way you can remember the formula for velocity of longitudinal transverse waves in different types of medium. How you derive this formula? You can derive with the help of dimensional analysis. Okay, I am going to derive a speed of transverse wave in a stressed string. You know, the speed of transverse wave on a string depends on mass per unit length of the string, that is called represented by mu, and tension T in the string. So you can derive the relation of velocity and this mass and this tension with the help of dimensional analysis. You know, dimensional formula for this mass per unit length is what? ml minus 1. Tension is force is ma. Its dimensional form is mlt minus 2. If you divide this 2 mu by t, it becomes this one TL minus 1 whole square. And this TL minus 1 is what? This TL minus 1 is formula for 1 by V, right now. So this is 1 by V square. So 1 by V square is mu by T, or you can say V is equal to C is any constant under root T by mu. In this way you can find speed of transverse wave in a stressed string. Also you can find with the help of this dimensional speed of longitudinal wave. The speed of longitudinal string depends on these two factors, density and bulk modulus, right? You know what is the dimensional formula for density, what is the dimensional for bulk modulus. Dimensional formula for density is what? ml minus 3. Bulk modulus is nothing but change in pressure per unit change in volume. Change in volume is dimensionless quantity. So what is the dimensional formula for change in pressure? Pressure is force per unit area, ma by a. So its dimensional formula becomes ml minus 1 t minus 1. When you divide this pressure, or you can say bulk modulus, and density, you get P by B, rho by B. Rho is density, ml minus 3, divided by bulk modulus. Bulk modulus is nothing but change in pressure, and pressure is ml minus 1 T minus 1. So you get this formula TL minus 1 again whole square, and this TL minus 1 is nothing but 1 by V whole square. From here you get V square is B by rho, or V equal to B by rho. This is dimensionless constant. So velocity of longitudinal wave is given by under root bulk modulus by density of the medium. In case of fluids, this is B by rho. In case of solids, this bulk modulus is replaced by Young's modulus. This is Y by rho. In this way, you can define speed of longitudinal and transverse wave with the help of dimensional analysis, or you just remember the formula for velocity in these two cases. Transverse wave velocity and longitudinal wave velocity. You can derive also, right? After this, next important topic is Newton's formula and Laplace correction, right? Okay, first, what is Newton's formula for velocity of sound in air? According to Newton, when sound wave travels in air or in a gaseous medium, the change in taking place isothermally, and hence, you know, velocity is given by under root of bulk modulus. It provides elastic factor, and divided by rho. It is responsible for inertial factor. So B by rho. But according to Newton, the change in taking place isothermally. So I am using here B isothermal. B isothermal means isothermal but modulus of elasticity. And you know, during isothermal process, PV is constant, right? So with the help of this equation, you can easily find that this B isothermal is equal to P. How you find this one? Like this one. According to Boyle's law, PV is constant, right? It means when you're differentiating both sides, PdV plus VdP equal to 0, and you get P equal to minus V dP by dV. And this minus V dP by dV is nothing but bulk modulus during isothermal process. So B isothermal is equal to P. So you can replace this B isothermal by P, then V becomes under root P by rho. So it's written here that this B isothermal is equal to P by rho. P is pressure of the gas and rho is density. And at standard temperature pressure, you know what is the value of pressure, what is the value of this density. After putting these values, you get 280 meter per second. How? You know this at STP, density is what? 1.293 kg per meter cube, and pressure is what? Pressure is equal to 1.005 Newton per meter square. So you put these values P and rho, you after calculating you get 2 meter per second, and this figure is over 60% lower than real speed of sound. What is real speed of sound? 320 meter per second, and this value is less than that one. So this means this formula is not true given by the Newton. After that, Laplace has given some correction in this formula. So what is Laplace correction? What is the formula according to Laplace? So according to Laplace, here in place of isothermal process, he assumed that during propagation of sound waves, the change takes place under adiabatic condition because gases are thermoinsulated and compression reactions are alternately taking place with a high frequency. So he assumed that the change taking place under adiabatic condition, not isothermal. So this B isothermal is replaced by B adiabatic. And you know, during adiabatic process, what is the formula? PV gamma is constant. So using this one, you have to calculate what is the value of B adiabatic, and in this way you calculate this PV gamma is constant. Differentiating both sides, you get gamma is ratio of Cp by Cv, right now. So after differentiating this equation, you get gamma PV gamma minus 1 dV plus V gamma dP equal to 0. In this way, P gamma equal to minus V dP by dV. It means this one is B adiabatic bulk modulus of air. So here B adiabatic is replaced by P gamma, and STP, you know what is the value of this P. Okay, so you can find in this way. Wait. B adiabatic is replaced by gamma P by rho, and you know it's where gamma 1 by 4 is, you can take 1 by 4. You know the value of pressure at STP, density. After putting these values, you get at STP 332 meter per second after putting all the values, and this value is near about the experimental value, that is 332 meter per second. Gamma is 1.4, this P is 1.0/5, and this density is 1.29. So you can get this value 331.17 meter per second. This velocity is near about 332 meter per second. So in this way, Laplace corrected Newton's formula. According to Newton's, he assumed change taking place isothermally, but Laplace assumed that the change taking place through adiabatic. The temperature does not remain constant, and pressure of the sound wave is in an adiabatic process. So in this way, you can derive, and this question is very, very important from examination point of view. After this, what are different factors influencing velocity of sound? Temperature, pressure, humidity, all these factors affects velocity of sound. First one is velocity of sound gas is inversely proportional to a square root of the density of gas. Velocity is inversely proportional to a square root of density of gas. So when density increases, velocity decreases. When density decreases, velocity increases. Second one is it is independent of the change in pressure of the gas provided temperature remains constant. It is not dependent on change in pressure. It is independent on pressure. Whatever pressure increases or decreases, velocity of sound remains constant. Third one is it is inversely directly proportional to a square root of its absolute temperature. Velocity is directly proportional to a square root of its absolute temperature. When temperature increases, velocity also increases. When temperature decreases, velocity decreases. And also velocity of sound in a moist air, when moisture is more, it's greater than the velocity of sound in dry air. So how it depends on pressure, temperature. On pressure, it is inversely dependent, and temperature it is directly dependent, and density it is independent. In moist air, velocity is more than in case of dry air. So these are different factors which influence velocity of sound. After this, next important topic is what do you mean by progressive wave, what is plane progressive wave, and what are its different equation, right? So traveling waves or progressive waves are same. What is this progressive wave? These are those waves which travels from one point to another in a medium. They are not at rest. It always travels from one point to another point in a medium. These waves are called traveling waves and also called progressive wave because they progress from one point to another. Both longitudinal and transverse waves can be traveling wave and it can move along one direction. So you know progressive or traveling, but what do you mean by plane progressive wave? If the wave is said to be plane progressive if all the particles of the medium vibrate simple harmonically. If particles vibrate simple harmonically, it vibrates about their mean position, it executes simple harmonic motion. All the particles execute simple harmonic motion, then that wave is called plane progressive wave. So what is the equation of this plane progressive wave, right? How you find the equation of this plane progressive wave. Each particle of a plane progressive wave executes simple harmonic motion of same period and amplitude but differing phase from each other. Assume that a progressive wave travels from this origin O, right? So at time in this positive x direction. Now at time t equal to 0, you know particle executes simple harmonic motion. And what is the equation of simple harmonic motion at time t equal to 0? The displacement of a particle at this time is given by y equal to a sine omega t. This is the displacement of a particle at time t equal to 0 at O position, where a is amplitude of the vibration of the particle. Now omega is angular frequency. Now after time t means particle travels through a small distance x with velocity v. So after time t is what? X by v. Particle disturbance reaches at this point P. Right now, this point P particle reaches. So what is the displacement equation of the particle at this point P? Okay, the disturbance will reach at point P after how much time? At initially particle is at O. After time t, it means x by v times later it reaches to point P. So displacement of particle at point P is nothing but displacement of the particle at time t equal to x by v times earlier at point O, because whatever things happen at this time t is taken place at O t times earlier. So displacement of the particle at P this position is equal to displacement at time t equal to x by v seconds earlier at point O. At point O equation is this one. So t times earlier means you just replace t by t minus x by v. This is the displacement of the particle at point P, right? So when you open this one, you get y equal to a sine omega t minus omega x by v. What is the value of this omega by v? Omega by v. Omega is what? 2 pi. N is nothing but frequency. 2 pi f you can write. Okay. 2 pi f by v. And this f by v is nothing but 1 by lambda. This f by frequency is 1 by lambda. And this 2 pi by lambda is nothing but k. So you just omega by v is replaced by 2 pi by lambda. 2 pi by lambda is k. K is propagation vector. So this is y equal to a sine omega t minus kx. This is the equation of plane progressive wave in positive x direction. When the wave is traveling in negative x direction, you just replace this minus x by this x by minus x. So this equation becomes y equal to a sine omega t plus kx. This is the equation of traveling waves in negative x direction. So you must remember these equations. What is the equation of plane progressive wave in positive x direction? Y equal to a sine omega t minus kx. And what is the equation of traveling wave in negative x direction traveling? Y equal to a sine omega t plus kx. Hope it's clear to all of you how you derive the equation of plane progressive wave. Now there are variation of phase with time and variation of phase with distance. Phase is what? Phase is this one, omega t plus kx. This is called phase. So how phase varies with time? So the phase generally continues with time. When you differentiate d phi by dt and d phi by dt, phi is what? Phi is omega t plus kx. Phi is omega t plus kx. When you differentiate that one, omega t plus kx. When you differentiate this d phi by dt, when you differentiate this one with respect to time, you get omega. So d phi is omega dt and omega is 2 pi by t. So this is variation of phase with time. And this capital T is time period. How phase varies with distance? So you just differentiate this phi, d phi by dx. When you differentiate this one, you get, case of positive x direction, minus k is there, negative result plus k is there. So d phi equal to minus k dx or minus 2 pi by lambda dx. Negatives are shown the wave propagates, the point is lagging behind it. Particle lags behind. When the wave is propagating in this direction, the particle is lagging behind it. So in this way, this is variation of phase with time, this is variation of phase with distance. After this, next important topic is boundary effects, and also you can say reflection of waves. Okay. So first, what do you mean by reflection of waves? Reflection of waves is nothing but the change in direction of wave upon striking the interface between two materials. When a wave strikes the interface between the two materials, then there is a change in direction of wave. It means bouncing back of wave. This is called reflection of waves. And depending upon the types of interface between the two medium, it means depending upon types of boundary, two phenomena takes place at this boundary. One is reflection and the one is refraction. When total reflection takes place, when partially reflection or refracted takes place, depends upon the types of boundary. So there are two types of boundary. One is open boundary and the one is closed boundary. Open boundary, in case of open boundary, what happens? When a wave strikes an interface in case of open boundary, it will get reflected as well as refracted. Suppose this is an open boundary, right? So when a wave strikes in this open boundary, what happens? It will get reflected as well as some part is refracted in case of open boundary. But if the boundary is closed or rigid boundary, you can say, then what happens? When a wave is incident on this interface, it will get completely reflected back. For example, waves striking wall or echo formation. So in this case, rigid boundary or closed boundary, wave is completely reflected back. In case of open boundary, some part is reflected and some part is refracted. So depending upon the types of boundary, this reflection of waves takes place. So first, reflection of wave at rigid boundary, when the boundary is closed. Rigid means closed boundary, right? So how reflection takes place at the rigid or closed boundary? Suppose first, this is a string and it is fixed at one end. This one is rigid boundary or fixed boundary, right? Now, when an incident wave, suppose this is an incident wave, it is moving in this direction. When an incident wave hits this wall, what happens? It means this exerts force on the wall. Then according to Newton's law, this wall also exerts force on this string, but the wall doesn't move, right? Therefore, no wave is generated at the boundary. At the boundary, no wave is generated, and no wave generated means here displacement or amplitude is 0. So, at the boundary, amplitude is 0. It means incident wave and reflected wave both are completely out of phase. Phase difference between incident and reflected wave is 180 degree or pi. It means If crest is entering, then trumps comes out after reflection from the rigid boundary. Phase difference between incident and reflected wave is 180 or pi degree. So two things are important when reflection takes place at this rigid boundary. At the boundary, amplitude is 0 and phase reversal of 180 or pi takes place. This zero amplitude, this point of zero amplitude or displacement is called node. So phase reversal 180 degree takes place and node is formed at the rigid boundary. What are the equations? How you write the equation of this incident and reflected wave? Suppose incident wave is coming in this positive x direction. So you know equation of progressive wave is what? A sine omega t minus kx. Now reflected wave, after reflecting through, if crest is coming, then trough comes out. It means amplitude is maximum but in negative direction, and also in negative x direction reflected wave moves. So negative x direction means in place of minus kx it becomes plus kx, and amplitude is also negative maximum displacement, so minus, you can also write a sine omega t minus kx. Okay, negative direction it is plus kx plus pi phase reversal takes place, and a sine omega t plus 180 degrees minus a sine omega t, so it becomes minus a sine omega t plus kx. This is equation of reflected wave. This one is equation of incident wave when reflection takes place at the rigid boundary. So when you add these two, net by superposition principle, net displacement is what? Net displacement is 0. So this is about reflection of wave at rigid boundary. These two points are very important. First point is the reflection of the rigid wall will takes place with the phase reversal of pi or 180 degree. This one is wall, right? And the point of zero displacement at the rigid or fixed wall is called node. After this, next one is reflection of waves at open boundary. What happens when the reflection takes place at open boundary? At open boundary, both reflection and refraction takes place. So here, when suppose this is incoming wave, incident wave, and after reflection through this open boundary, it bounces back in this direction, opposite direction, negative x direction. But if crest is coming, again reflected wave is also crest. If trough is coming, then reflected wave also becomes trough. It means no phase difference between incident and reflected waves. So these 2 points are important here. The reflection at open boundary takes place without any phase change. If there is no phase change, it means amplitude is maximum at the open boundary. These 2 points are important. Phase difference between incident and reflected wave is 0. No phase difference between incident and reflected wave, and amplitude is maximum. So how you write the equation of these two waves? Suppose incident wave is a sine omega t minus kx, and the equation of reflected wave is in negative direction. Just replace minus kx by plus kx. Amplitude is same. Here also crest, here also crest. Here also trough is formed, here also reflected trough is formed. So a sine omega t plus kx, when you add these two, maximum amplitude is there at the open boundary. So these 2 points are important about reflection takes place at open boundary. At the open boundary, there is a point of maximum displacement. That maximum displacement amplitude is called antinode. Minimum displacement is called node, and maximum displacement is called antinode. And reflection at the open boundary will takes place with a phase reversal of 0 degree, right? Hope it's clear to all of you. After this, I'm going to discuss about principle of superposition of waves. What is this principle of superposition of waves? Because there are a number of applications which is important about this principle, right? What is this principle of superposition of waves? When two or more waves overlap, the resultant disturbance is equal to algebraic sum of individual displacement. Suppose one wave is going like this one, another wave is going like this one. When these two or more waves overlap at one point, then the resultant displacement is equal to sum of disturbance due to individual waves. Let us suppose that y1 and y2 represent displacement of the particle due to these two individual waves. So total displacement at any point y is equal to y1 plus y2. This is principle of superposition of waves. Now there are different applications of superposition of waves. First one is a stationary wave, then interference, then waves. How a stationary wave is formed? A stationary wave are those waves which is not moving. It means those waves which is at rest. When two waves with same frequency, wavelength and amplitude traveling in opposite direction, and when these two waves interfere, they produce a standing wave, or you can say stationary wave. Amplitude, frequency and wavelength all are same, but the waves are moving in opposite direction. When these waves interfere, a stationary wave is produced, right? Interference. Here also two waves having same frequency, everything is same, but they are moving in same direction. In a stationary wave, opposite direction. Here both waves are moving in the same direction. When these waves interfere, interference phenomena takes place. This, right? And last is beats. Beats is nothing but here also two waves which are moving in the same direction like interference, but here there is a small difference. These two waves have nearly same frequency, slightly different frequencies there, and amplitude traveling in the same direction. Then this forms beat. It is a phenomenon caused by two sound waves of nearly same frequencies and amplitude but traveling in the same direction. For example, tuning of musical. So this interference is studied in class 12th, right? No need to study here. And beats, little bit definition is there. Now here I am going to discuss in detail about a stationary wave or a standing wave. What is stationary wave? How it is produced? How graphically you represent stationary wave? What are the equations to represent a stationary wave? All these things we will discuss, right? So next topic is, first one is graphical representation of stationary waves, right? Okay, what are stationary waves? When two waves traveling in opposite direction having same amplitude and frequency, right? Suppose there are two waves. One wave is moving in this direction and another wave is traveling in opposite direction having same amplitude. Superimpose, then a standing or stationary wave is formed. This is graphical representation how stationary wave is formed. Suppose here there are two waves. One is represented by red line, another one is represented by blue line, right? When two waves superimpose traveling in opposite direction having same amplitude, a stationary wave is formed. So this one complete cycle is of wavelength lambda. If you divide this lambda into different parts, this one is half cycle, it means lambda by 2, and this one is lambda by 4, and this point is 3 lambda by 4, right? Now initially when these two waves traveling in opposite direction, what happens? These two waves are in same phase, right? Now same phase means crest of one wave superimpose on the crest of another wave, trough of one wave superimpose on the trough of another wave, and hence what happens? When initially both are in same phase, the resultant amplitude decreases when in the same phase, and wave is formed like this one. Resultant amplitude maximum. Maximum means here first antinode is formed. Now after time t by 4, what happens? After time t by 4, each wave advances lambda by 4 distance, right now? One wave is moving in this direction and this another wave is moving in opposite direction. Both wave after t by 4 advances lambda by 4 distance in opposite direction, and it is like this one. This blue one, after this t by 4, this part passes, so only this part is left, right? Now starting from this one. So this is blue one, right? And in red part, this part lambda by 4 distance cover. So this wave starts from this point, right? And when these two waves superimpose again here, crest of one wave superimpose on the trough of another wave. It means both are out of phase and hence resultant amplitude is 0. So at t by 4 time resultant amplitude is 0 and node is formed, right? Again after t by 2 both wave covers half distance. So this red one after covering half distance, it starts from this point, and blue one after covering half distance, it starts from again this point. Again at t by 2 both are in the same phase, right? Crest of one coincides with the crest of another, and again in negative x direction maximum amplitude is formed. It means antinode is formed. Then again after 3 t by 4 time, when both wave advances 3 lambda by 4 distance, then these two waves are like this one, and in this case both are in out of phase, and here minimum displacement is there. Again node is formed. Then at time t, again both comes to the original position, crest of one coincide with the crest of another, and this type of wave is formed. Maximum displacement is antinode is formed. So one time antinode, another then and node, again antinode, then node, then again antinode. So this type of wave is formed. These two waves just vibrate about their mean position. When these two waves travel in opposite direction, superimpose, these two vibrates about their mean position. Always at this point, node is there. Always at this point, antinode is there. Again minimum displacement, node is there. Then again at this point, antinode is there. Then again at this point, node is there. Minimum displacement is node, maximum is antinode. So these two waves, when superimposed traveling opposite direction, vibrate about their mean position. Node at one point always node is formed, another point always antinode is formed. In this way, a stationary wave is formed. Hope it's clear to all of you. Try to understand this topic. It's very important. Right? Now, after this, there is analytical treatment of stationary or standing waves. How two waves traveling in opposite direction superimpose each other and a standing wave is formed. I am going to derive the equation of that standing wave. Suppose one wave is traveling in the positive x direction like this one, and another wave is traveling in the negative x direction like this one. So equation of this wave is what? A sine kx minus omega t. This is traveling along positive x direction, right? Now equation of this wave, it is traveling in opposite direction having same amplitude, same frequency, only direction changes. So you replace this minus by omega t. So A sine kx plus omega t traveling in negative x-axis, where A is amplitude of the two waves, same amplitude, and omega is angular frequency, and also k is propagation constant. It is given by k equal to 2 pi by lambda. Now using superposition principle, these two waves combine and forms stationary wave. How combine? Y is equal to y1 plus y2 according to superposition principle. When these two waves combine, A sine kx minus omega t plus A sine kx plus omega t. You know sine A plus B is what? 2 sine A plus B by 2 cos A minus B by 2. Right? So applying this formula, you get y equal to 2A sine kx cos omega t. This 2A sine kx is constant. You take it as A dash. So y is equal to A dash cos omega t. And you know y equal to A sine omega t or cos omega t is what? It is equation of simple harmonic motion. It means simple harmonic motion means particle vibrates about their mean position. So this is the equation of standing or stationary wave which vibrates about their mean position, but their node antinode is always fixed, and it looks like that the wave is stationary or at rest, right? So this is the equation of stationary waves, y equal to 2A sine kx cos omega t. Okay, and this type of equation represents standing waves. It means the waves neither travel towards left nor towards right. It is at rest. It only vibrates about their mean position, up and down, up and down. During their vibration, there is minimum displacement like this one, and their maximum displacement like this one. This maximum displacement amplitude is called antinode, and this minimum displacement or amplitude is called node. Okay. So position along which amplitude of oscillation is always 0 is called node, and where maximum oscillation is there, amplitude maximum, is this called antinode. So these are about standing or stationary waves. Now where node or antinode is formed, okay, so position of node you can find in this way, right? At nodes, what is this? Amplitude is 0. So what is the formula of amplitude in this equation? 2A sine kx is amplitude, right now. So you put 2A sine kx equal to 0 in this equation. Okay. So after calculating, you know kx is 0, pi 2 pi, and k is what? 2 pi by lambda. From here you get x equal to n lambda by 2. This is the position of node. If you put n equal to 0, 1, 2, it means at x equal to 0, node is formed. Again 1, it means at lambda by 2, again node is formed. Then 2, it means at lambda, again a node is formed. 0, lambda by 2, lambda, nodes are formed. right? Now, position of antinodes. It is the position where amplitude is maximum. It means 2a sin kx plus minus 1. So, when sin theta is 1 at 0, pi by 2, 3 pi by 2, like this one. Okay, now? So, here after calculating this one, you get x equal to 2n plus 1 lambda by 4. This is the position of antinode. When you put n equal to 0, 1, 2, 3 dash, n is 0 means at lambda by 4, first antinode is formed. When n is 1, it means 3 lambda by 4, second antinode is formed. You know, one complete cycle is of lambda distance, right now? So, this one is lambda by 2, this total is lambda. This half is lambda by 2 and this one is lambda by 4. This distance is lambda by 4. This one is lambda by 2. So, at 0, at this point, lambda by 2 this position and at lambda this position node is formed. It means minimum amplitude. And at lambda by 4, 3 lambda by 4, then after that 5 lambda by 4, 7 lambda by 4, maximum amplitude. Antinode is formed. So, this one is lambda by 4. This one is 3 lambda by 4. In this way, different antinodes are formed. So, node, then antinode, then node, then antinode, then node. In this way, a stationary wave is formed when two waves traveling opposite directions superimpose having same amplitude. What is distance between these two nodes? Distance between these two nodes is always lambda by 2 when you take difference of these two. First, second node, second, third node, third, fourth node, and also distance between two antinode is also lambda by 2. So, this point is very, very important. The distance between any two successive antinodes or nodes is always equal to lambda by 2. And distance between these two node and antinode is always lambda by 4. You must remember these 2 points. Very, very important about stationary waves. So, there are different characteristics of standing waves. Standing waves are stationary. Okay. The disturbance do not travel in any direction. It only vibrates about their mean position up, down, up, down. Position of node, antinode is always fixed. It just moves up, then down, moves up and down. Maximum displacement, then minimum displacement about their mean position. So, it does not travel in any direction, right? Standing waves having points of zero amplitude is called nodes and points of maximum amplitude is called antinode. There will not be any flow of energy across any section of the medium. Distance between two successive nodes or antinodes, already told you, no? Distance between two successive nodes or antinodes is always equal to lambda by 2, where distance between antinode and its adjacent node is always lambda by 4. The pressure change is maximum at node and minimum at antinode. So, these are some characteristics of standing waves. Now, after this, I am going to discuss how standing waves is formed in a string and organ pipe. First, stationary waves on a string which is closed at both ends, right? Closed or fixed at both ends. And you know, when a string is fixed at both ends, then at these ends, there is no displacement at the boundary and always node is formed. You just remember this point. In case of a string fixed or closed at both ends, at the both ends, always node is formed. Minimum displacement is there. And one more thing, you know that speed of transverse wave on a string is given by V equal to root over T by mu. Mu is mass per unit length and T is tension in the string. Now, consider a string of length L which is fixed at both ends, and at both ends always node is formed. Now, I am going to discuss how standing waves is formed. Different modes of oscillations or vibration. First mode of vibration, or you can say first harmonic. For this, you just plug the string, this string in the middle and then released. What happens? It vibrates with nodes at its ends and one antinode is formed in the middle. This one is first mode of vibration. In this one, two nodes are formed at the ends and one antinode is formed in the middle. And you know, this string is of length L and distance between node and this node is what? Distance between two consecutive nodes is always, yes, lambda by 2. So, you can write that L is equal to lambda by 2 or lambda equal to 2L in case of first mode of vibration. Now you know frequency is given by what? Frequency is V by lambda. V is this one, root over T by mu. You put the value of lambda equal to 2L, you get frequency equal to V by 2L. This is the lowest value of the frequency, right? And this frequency is called fundamental frequency or fundamental node. Here in this case, in case of first mode of vibration, 2 nodes at the ends and 1 antinode in the middle is formed. Now after this second mode of vibration, you can say second harmonic. For this one, you plug the string at the 2 points, right? So in this case, at the ends always node is formed, 1 node is formed in the middle also, and 2 antinodes are formed in between them. So in this case, 3 nodes and 2 antinodes are formed, and you know distance between nodes and nodes is what? Lambda by 2. Node and node is what? Lambda by 2, and total length of the string is L. So L is equal to lambda in this case, second mode of vibration. So frequency becomes F2 equal to V by L. This frequency is called second harmonic, or you can say first overtone. Fundamental frequency, after this fundamental frequency, next frequency is called first overtone. Here 3 nodes at the ends and 2 antinodes are formed. After that, third mode of vibration. In third mode of vibration, what happens? In third mode of vibration, you plug the string from the 3 points. So in this case, at the end points, nodes are formed, and again 2 nodes are here also. So 4 nodes and 3 antinodes are formed in case of third mode of vibration or third harmonic. So this is equal to lambda by 2 between 2 nodes, again lambda by 2 between 2 nodes, and again lambda by 2 between these 2 nodes. It means 3 lambda by 2. So L is equal to 3 lambda by 2 and lambda equal to 2L by 3. So you can find the frequency in third frequency is V by lambda, and put the value of lambda, you get 3V by 2L, and V is equal to root over T by mu. This frequency is called third harmonic, or you can say second overtone. In this way, standing wave or stationary wave is formed in case of a string like this one. Okay, this is the stationary wave in case of a string fixed at both ends. At both ends always node is formed. Okay. After this, next topic is how stationary waves is formed on a string fixed or closed at one end only. When a string is fixed at one end only, it means at close end always node is formed, and open end always antinode is formed. So in this case, at one end always node is formed, and another end which is open, that is suppose a string is of length L. So at length L always antinode is formed. At that place amplitude is maximum. Here also different modes of vibration. First mode of vibration of first harmonic. For first mode of vibration, here one end is fixed. At this point always node is formed, and this end is open. So at this point always antinode is formed. So in case of first mode of vibration, this distance between node and antinode is what? Lambda by 4. So this length of the string L is equal to, the string is of length L, x equal to L to x equal to 0 to L. So L equal to lambda by 4, you can say lambda is 4 by L. From there frequency, you got the frequency lambda equal to nu by 4L. This frequency is again lowest frequency. It is called fundamental frequency of first harmonic. Here one node and one antinode is formed. In case of second mode of vibration or second harmonic, again at fixed end always node is formed, and open end always antinode is formed. Plug the string at the 2 points, then here again this type of standing wave is formed in case of second mode of vibration. Here at this place also antinode is there, at this place node is there. So 2 nodes and 2 antinodes are formed in case of second mode of vibration. And you know distance between this node and antinode is again lambda by 4. Antinode and node is lambda by 4. Again node and antinode is lambda by 4. It means 3 lambda by 4 is equal to L, or L equal to 4L by 3. From there you get first frequency as 3V by 4L, or 3 times fundamental frequency. This frequency is called second harmonic of first overtone. Similarly, you can find next frequency, third mode of vibration. This is 5 times of fundamental frequency. Next frequency, fourth mode of vibration, 7 times of fundamental frequency. So for a system which is closed at one end and open at other end, we will get fundamental frequency 1 and all other odd harmonics. Like this second mode of vibrations, first overtone is what? 3 times of fundamental frequency. Next 5 times. It is an integral odd multiple of this fundamental frequency. So one fundamental frequency is there and all other frequencies are odd harmonics of that fundamental frequency. This is about a stationary wave which is fixed at one end, right, and open at one end. After this, last topic of this chapter is stationary waves in open organ pipes or air columns. It is a musical instrument. What is this organ pipe? It is a musical instrument, right? So in this case also, one is open organ pipe and another one is closed organ pipe. In case of open organ pipe, both ends open, right? So both end open means always at the open end always antinode is formed, right? So how stationary formed in case of this open organ pipe? First one is fundamental mode of vibration. So at both end always maximum amplitude antinode is formed, in between them one node is formed. This is first harmonic, and here a string is of length L again, and distance between this antinode and antinode is what? Lambda by 2. Okay, so this L equal to lambda by 2. From here you get lambda equal to 2L. Of first frequency is V by lambda. It means F1 is equal to V by 2L. This is fundamental frequency. Now second mode of vibration or second harmonic, or you can say first overtone. For this one again at the end points it is open organ pipe. So both ends open. So here antinode is formed. So like this one second harmonic is formed. In this case one antinode 2 and another one 3 antinodes. 3 antinodes and 2 nodes are formed. And distance between this is what? This lambda equal to, yes, this one is lambda by 2. Antinode, distance between this antinode and lambda by 2. Again this one is lambda by 2. Antinode and antinode. So in this case lambda is there. This L is equal to lambda. And from there you get F2 equal to V by L. In the same way, third harmonic, again here 1, 2, 3 and 4. 4 antinodes are formed. And distance with 2 antinodes is always lambda by 2. So here 3 lambda by 2 is there. So L equal to 3 lambda by 2. In this way you get F3 equal to this one. And this ratio of these frequencies are 1:2:3. So for a cylindrical tube which is open at both ends, the harmonic exits in the tubular or integral multiple of its fundamentals in the ratio 1. And general expression for this lambda is equal to 2L by N, and frequency is F equal to V by lambda, means F equal to NV by 2L. This is about stationary waves in open organ pipes or air columns. And one more last topic of this is how stationary waves is formed in closed organ pipes. Closed organ pipes means one end is open and the other one is closed, right? So at the closed end always node is formed, at the open end always antinode is formed, and these are different modes of vibration. In first mode of vibration, this distance is what? At the open end antinode is formed and closed end node is formed. Distance between these two is what? Lambda by 4. So this L is equal to lambda by 4. Here lambda is 4 by L, and first fundamental frequency or first harmonic is V by 4L. In the same way, next mode of vibration, and this is called not second harmonic, third harmonic. Why? Because here we get the frequency as an 3 times of this fundamental frequency. That's why it is called third harmonic of first overtone. In this form, always at the closed end node is formed, open end antinode is formed, right? So this is third harmonic of first overtone. Here 2 nodes are formed and 2 antinodes are formed, and distance between this string is of length L. So node is lambda by 2, and again node and antinode is lambda by 4. So 3 lambda by 4. This length is equal to 3 lambda by 4, and F3 is equal to 3 V by 4L, or you can say 3 V by 4L is what? F1. 3 times fundamental frequency. In the same way, fifth harmonic is shown in this figure, and this is equal to 5 times of this fundamental frequency. So these are odd harmonics are there, right? In this case all are odd multiple of the fundamental frequency. Other frequencies are there. So you just know how to draw stationary waves in these closed organ pipes, open organ pipes in a closed string, open string. It is enough for you, right? And you just know what is the frequency of first mode of vibration, second vibration. These are all about stationary waves in a string and organ pipe. And one last definition is there, beat, already discussed when we discuss in about superposition principle, 3 phenomena. So what is beat? Beat is nothing but phenomenon of regular rise and fall intensity of sound when two waves of nearly equal frequency traveling along the same line, the same direction. When two waves are traveling in the same direction, they are slightly different in frequency. In that case, when they superimpose each other, beat is formed. One rise and one fall in the intensity of sound constitutes one beat, and the number of beats per second is called beat frequency. It is given by Fp equal to F1 minus F2. F1 is frequency of first wave, F2 is frequency of second waves, and when these two waves interfere having slightly different frequency, beat is formed, and beat frequency is F1 minus F2. F1 being always greater than F2. So this is about beat, and this is the last topic of this chapter. Okay, students. So with this, I am going to end my class. Hope you like this one short series of class 11th physics. If you liked it, then don't forget to subscribe my channel. Okay, students, then keep revising and stay tuned with this channel. Thank you.